Integration by substitution applies when we have the integrand in this form, f prime of g of x multiplied by g prime of x. Notice this is a hard function to integrate. So the idea behind substitution or u-Substitution is to make this a way easier function to integrate. Notice in here the integrand looks very familiar. It actually came from the chain rule when we take the derivative of a composite function of g of x. It's gonna be equal to the derivative of the outside, which is f prime of g of x, multiplied by the derivative of the inside, which is g prime of x. Note here, the derivative of the inside function is g of x. Therefore, the integrand is gonna be equal to f of g of x, and then plus c by the chain rule. Therefore, we can notice that u-Substitution is opposite to the chain rule. So the u-Substitution is in case of integration, and the chain rule is in case of differentiation. Here again, we want to make this integrand a way simpler form to integrate this function. So I'm going to use u-Substitution. First step, I'm going to equal the u function to the inside function. In this case, it's going to be g of x. Then I'm going to differentiate the function u of x. So it's going to be du over dx, and then going to be equal to g prime of x. Now I'm going to move the dx to the other side. That's going to be du equal to g prime of x dx. Notice in here that g prime of x dx is the one on the top. Now we are ready to the substitution. So the integral on the top going to be equal to the integral of alpha prime, and remember g of x now gonna be equal to u. So alpha prime of u and then g prime of x dx gonna be equal to du. We can see that after the substitution, the integrand is a way simpler form when we can find the integral of this function. It's gonna just be f of u plus c. Now the second step is to back substitute the function of u. Remember, u is just g of x. Therefore, the resulting integral gonna be equal to f of g of x plus c, which is exactly the same thing we found using the chain rule in the top. Now we want to find the integral of 3x squared cosine x cubed dx. So we cannot integrate this function. This is a way complex function. So we want to check if u-Substitution applies in here to make this integral into a way simpler form. So we want to look into this function and find a term and then find the derivative of that term on the same function. Here note when we take the derivative of x cubed, it's going to be equal to 3x squared. So notice that 3x squared is actually on the function. Therefore, u-Substitution applies. And the inside function gonna be equal to x cubed. So u of x gonna be equal to x cubed. Du over dx gonna be equal to 3x squared. Now I'm gonna move dx to the other side. Now we are ready to make the u-Substitution. So the integral on the top, what I'm gonna do, I'm gonna arrange that. I'm gonna bring 3x squared in front of dx. Now we can see clearly that 3x squared dx gonna be equal to du, and then x cubed gonna be equal to u. So the substitution gonna be equal to the integral of cosine of u du. Notice this is a way simpler form than the given function. We already know what's the antiderivative of cosine of u. It's gonna be sine of u plus c. Now we can move to the second step, which is back substitute the function of u. Remember, u is x cubed, so we'll have sine of x cubed plus c, and that is the resultant integral. So now let's check that our solution is correct. So what I'm gonna do, I'm gonna assign the answer to f of x, which is the antiderivative, and then I'm gonna find the derivative f of prime of x. Here I'm gonna use the chain rule, so it's gonna be the derivative of the outside, which is sine, and then the derivative of the inside is x cubed, so the derivative gonna be 3x squared. So now I'm gonna bring 3x squared in front of cosine, and you can notice this is exactly the integrand.